Okay, welcome to part 2. Now we're going to do another exponential function, but this time there's going to be a fraction in our for b. All right, and there's no a. The a is just 1. So take a look at the bottom of your page where we have f of x equals 1/2 to the x power. So remember that our function for exponential functions is f of x equals a times b to the x power. So in this situation, our a is just 1, okay? And then our b is 1/2 to the x power. All right, let's go ahead and get started. We'll start by filling in our chart. So if we have -2, if x is -2, then that means I'm going to have 1/2 to the -2 power. Now remember, if I have a -2, then that means I have 1/1/2 to the second power. So really, so now I have this double fraction, right? So 1 divided by 1/2, if I think about what that means, 1 divided by 1/2 to the second power, then that just is really multiplied by the reciprocal, right? Keep, flip, change, KFC. So now I have 1 times 2 to the second power over 1. So now I have 1 times 2 to the second power, which is 4. Notice that I had no negative numbers. Just because my exponent is a negative does not mean that my number, my value, is a negative. The negative exponent just means that it becomes a fraction. Okay, cross the line, change the sign. All right, let's do the next one. 1/2 to the -1 power is really just 1/1/2 to the 1 power, which is just 1/2. So 1/1/2 was really 1 divided by 1/2, which is the same as 1 times 2/1, so that becomes 2. All right? And then we have 1/2 to the 0 power, and any number to the 0 power is not 0. I know that that's what everyone wants to say, but it's not. Any number to the 0 power is what? 1. Okay? And then we have 2 to the 1/2 to the second power. So 1/2 to the second power is just 1/2 times 1/2, which is 1/4. And of course, we always have to, because I forgot to put the 1 in there, 1/2 to the 1 power would be 1/2, right? And then 1/2 to the third power is just 1/2 times 1/2 times 1/2, which is 1/8. Now let's go ahead and graph these. So -2, we say -2 is 4. So if we go to -2, we go 1, 2, 3, 4, right there. And -1 is 2, right there. And 0 is 1, okay. And 1 would be 1/2, so I'll go ahead and do it right there. And 2 would be 1/4, which is a little bit, half of that. And then 3 would be 1/8, which is going to be very hard to graph. But you get the idea. So notice that, and if I went backwards and did -3, it would end up being 4, 5, 6, 7, 8. So you can see that in this situation, this exponential is looking something like this. Okay, so it's kind of coming down like that. So now let's talk again about the x-intercept. So my first question is, if I continue to go in the positive direction, if my x is in the positive direction, if I have 1/2 to the x power. Well, that just means 1 half to the x power, because this is 1 to the x power and 2 to the x power. And so you can see that I'm never going to get to 0, am I? I'm never going to get that y is 0. So I have no x-intercept. Once again, I'm approaching the x-axis, but I'm never going to get to y equals 0. All right? The y-intercept in this situation, where it crosses the x-intercept, is, or the y-intercept, where it crosses the y-axis is 0, 1. Okay? And that will always be because my a value, in this case, was 1. So whatever my a is, that's my y-intercept. That's where my exponential function crosses the y-axis. You can see up here that it crossed at 3, and that's because my a was 3, right? When y is 0, or when x is 0, then the base becomes 1, and so whatever the a is, that becomes my y-intercept. My asymptote is the same. In this situation, it's getting very close to, but never reaches y equals 0. So remember that our asymptote is that horizontal line that the exponential function will get very, 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 very close to, but will never reach it. All right? Our domain, once again, all of our x values, if you look along the x-axis, we can keep going and going and going as far as we want. X can be any number, can be any of the real numbers. But the range, the y values up and down, you'll see that there are no negative y values. We don't have anything down here below the y-axis. That's because the range is y is greater than 0. We don't even have a y is 0, right? That would have been the x-intercept. And in this situation, is it increasing or decreasing? Well, it's decreasing. Now, I want you to make a few assumptions. I want you to figure out a few things. I've already told you that the x-intercept doesn't exist on these exponential functions. It is actually, it's because the asymptote is the y-axis, and so it's never going to get to y equals 0. The asymptote is not the y-axis. The asymptote is the x-axis, all right, the horizontal x-axis. So, we call it y equals 0 because that's where x can be anything, but y is 0. But tell me, can you come up with a rule or some way that you can know whether an equation of exponential function is increasing or decreasing? Think about it. Look at our two different examples. We've got 3 times 2 to the x power was an increasing function, and 1 times 1 half to the x power was a decreasing function. Do you see anything? Well, it doesn't have anything to do with the a part, the number that gets multiplied by the base, but the base certainly has a key part. Notice that the b, or the base of our exponent, the b is called the base, and the x is called the exponent, right? The b, the base, when it's an increasing, is a whole number, okay? It's a whole number. And when it is decreasing, it is a fraction. So I think we could come up with a little rule that said if the a is greater than 1, okay, then it's going to be increasing. If it's less than 1, then it's going to be decreasing. The only thing that we need to really remember, though, is that the a can't be 1, because if it's just 1, it ends up just being a straight line, all right? You can't have 1 to the x power because you're just always going to get 1. So it can't be 1. And it can't be a negative number, because if it's a negative number, then we get positive and negative versions, and it sort of makes this sort of Y-shaped thing that sort of branches off. So those are just a few things to notice and to remember, and I'd like you to take a look at my little remember on the side. Domain is all of the x values of the function. Remember, the domain is all of the x values of the point. Every point on this function has an x value and a y value, and the x values are the domain, and the y values are the range, all right? The asymptote is the horizontal line that the function approaches but never reaches. And in increasing functions, b is a whole number, and it doesn't actually have to be a whole number, it just has to be b is greater than 1, all right? And the decreasing functions is b is less than 1, but greater than 0, right? So it can't be a negative number. B can't be a negative number. So it's always a fraction. It's in between 0 and 1, all right? Now's the time to write a key idea. And a key idea is not what you learned. A key idea, so it's not, you don't write down, I learned about exponential functions. Tell me something important that you need to remember about exponential functions. It could be that increasing functions, the b is greater than 1. Decreasing functions, the b is less than 1 but greater than 0. That would be a key idea, something that you want to remember that will help you when the time comes for taking a test. It could be what's an asymptote, and so you don't write what is an asymptote, you tell me what the asymptote is. The asymptote is the horizontal line that the function approaches but never reaches. So think about what's an important idea, a key idea that you need to remember, and that's what you write right here. All right? I'll see you in class.